I lived in New Orleans for a few years while I was in graduate school, and it's one of my favorite places in the world. It's an amazing city for the food, the culture, the people. And I just saw an article that really scared me and made me feel really bad for the place. The article was in The Guardian, and it references the fact that New Orleans is hitting a point of no return. And the city and the residents must basically be relocated due to rising sea level. And this was referencing a article that was published in Nature Sustainability that was just published on May 4th, so it just came out. And it really cuts to the chase that no matter what happens in terms of diversion or trying to stem the kind of degradation of the marshes that are protecting New Orleans and the coastal Louisiana area, that nothing is really going to help. And so one thing I wanted to take a look at was using Esri's Landsat Explorer and some of these applications. Are there ways that students could measure this degradation, understand it, or see if there are ways or projects or programs that could help slow this loss and actually help prevent this from happening? And so one of the things that is taking place is there are diversion projects that have been built and been stood up across the Louisiana area. One of these diversions is referred to as the West Bay Sediment Diversion. You can see here was operational in 2003. And using the Landsat Explorer, I wanted to take a look at what this area looked like prior to this diversion. So you can see here we have the red that's showing kind of the vegetation because we have a color IR. And I've selected on the left here an image from 2002 that was prior to this diversion getting in place. And then on the right, I've selected one from a similar time. So I want to be cognizant of, I didn't look at the rainfall events or anything else, but at least getting kind of the same time frame, time of year here. And so I've got another image from March. And let's do a quick swipe to compare these two areas. So we can see here on the left, this really big open spot of water, and this was kind of the main part of the project. And if I swipe to the right here, you can see the cut that is taking place here to let the river then deposit sediments. And this is a location here where they're actually coming in and dredging and depositing sediment directly, and then seeing how this is building up and those impacts. And even along this segment here, over here, and if we scroll a little bit, you can really see that there is a lot of kind of growth happening tidally here. And still this kind of getting eaten away a little bit down in the south, but that it's having an impact. And so to measure this a little bit better, kind of some neat tools inside of the Landsat Explorer, I'm now doing a swipe to do a compare between these two locations, and let me hit analyze. And instead of doing this mask, right now it's saying it's using that color IR. We're doing the water index. I could change this to say vegetation, so I'll do that. It's going to pick those areas that are, the pixels of vegetation. And then instead of just looking at that index, which looks pretty good, I'm going to say change detection on the bottom here. So it's going to pick between my scene A, my scene B, and then I'm going to view the change here for the vegetation index. And let me swipe this down a little bit to either see the growth or the loss. And actually I want to do the inverse of this because we want to see where the growth has taken place. You can see there we're kind of filtering out those pixels that are really just filling in for us for water. And so now we're getting an on-the-fly analysis to show me where those areas of growth that have taken place. And so in this area, we've seen about 30 square kilometers of change over that time frame of roughly 24 years in terms of areas that have actually seen an expansion in vegetation in this coastal area. So let's look at a spot where a diversion is not taking place and see if there's growth along the coastal area or not, and what kind of growth is taking place. So I just panned the map over to a location that's just south of Venice, Louisiana. So let me zoom out a little bit so you can see that. So we've got Venice showing here. And this is an image we're looking at on the left-hand side, which is from 2002. So this is getting right near kind of down the bottom of the Mississippi River. And if I zoom in a little bit, I've added the same color IR renderer or filter to the image to be able to see the vegetation a little bit more clearly. And let me zoom in one more, or we'll keep it here. And on the right-hand side, I've selected an image from 2006. And so here, the colors aren't as bright, which is fine, but we can see really clearly the amount of kind of loss in land that's taking place here. And again, as we just did in that last exercise with some of the imagery around the diversion, we can go here to Analyze, Analysis, and I want to see the difference in vegetation between these two locations. And so I have the vegetation index on, and let me adjust this a little bit. And again, instead of, right now we're seeing the areas of growth, and we want to look at the inverse. You can see maybe there's a little bit of kind of additional wetland or kind of growth that happened in some of these locations. And this was that diversion area. There was also a diversion project here. And so let's look at some of these other locations and see what the loss looks like. So I'm going to drag this over, and let's just get some of that pixelated noise out. You can see our ocean kind of pixels, and if we can try to ignore that, I'll zoom in a little bit. You can now see we've got about 40 square kilometers of loss of vegetation. And if I do kind of a quick sanity check to compare those two locations, you can see that probably shows pretty clearly. We've got growth in here in some of those diversion locations, then also a lot of loss of wetland and land over in these locations further from those diversions. So I wanted to highlight really quickly how students can take this application and make some really quick measurements and analysis for a real world problem like this. Again, this article kind of brought me down a bit, but the ways that students can look at this and see the impact of projects to help ameliorate or what it means to have diversion projects in place can be really, really powerful. Today, there is still a diversion project that was slated to be built and is currently been canceled by the Landry administration in Louisiana. So this would be another major initiative to help restore the wetlands and restore coastal Louisiana. And if this got in place, again, these projects can have a major impact in preserving the ecosystem and the Louisiana coastline. So please go check out this application. Think of ways you can introduce it to your students for either coastal change, could be wildland, could be forest cover, could be urban change. You can make measurements and you can compare, where these different projects have happened and what the impact of them has truly been. Something I did really, really quickly was just have a look at where current diversion projects are, when they became operational. Then I was able to just kind of zoom to those locations using XY coordinates, and I could quickly see what that impact was. I could make an awesome little chart or visual for that to see if there was really an impact from these programs and these projects. So please go explore. Again, this is the Landsat Explorer. If you go to the Living Atlas and apps, an amazing suite of applications and tools you can use in the classroom today. Thanks.